Alright, last day of notes. We are going to start with looking at combinations and permutations. Okay, so these aren't too bad. There's a couple things to start off with knowing. In probability, there's two words that mean something. And in regular math, for instance, in probability, if you see the word and, you're going to multiply. If you see or, you're going to add. Whereas in regular math, if you see the word and, you add. And if you see the word of, then you multiply. Okay? So you guys have been doing this for the longest time, like whenever you have f of x. These types of ofs are the only times you don't multiply, but other than that, like if you're going to pay someone at a rate of $45 per hour, okay, it's going to be 45 times h. So the per of is the same kind of interpretation. That's multiplication. But again, probability, you're going to multiply when you see the word and you're going to add when you see the word or. Huge right off the bat. All right, so here we go. A license plate has 3 letters, and then it has 3 numbers. How many letters or how many such license plates are possible? Okay? How many different things can I choose from for the first placement value, if you will? 26. There are 26 letters in the alphabet, so there are 26 things that you could choose from for this first thing. How many for the second one? 26. Third? 26. The biggest reason why you put 26, 26, and 26 and not 26, 25, and 24 is because it never said without replacing it. Okay, this is with replacement. That means you can, as soon as you pick that letter out, throw it back into the bag, if you will, and you can choose it again for the next letter. Okay? How about for the numbers? How many digits can you choose from? 10, because it includes what digit? 0. So you could have 10 for this one and 10 for this one. This is not the case all the time. Now look, there's a word that should be up here that is not. But it means to multiply all these numbers together. What's the word? And. So it would be 26 letters, and then you would pick another 26 letters, and then, and all the times that you're saying and, I know I just said and then, but it's mostly and, this is when you're going to multiply these possibilities. Okay, so you get 17,576,000 different ways that you could create a license plate. So, 17 million. Do you think there are 17 million drivers on the road right now?
License plates have 4 numbers.
License plates now have 4 numbers. And the reason why they have added this 4th number is because they ran out of randomized license plates. Okay? You don't, when you use a license plate and then you sell the car or whatever, that license plate is unique to you. They're not going to reuse it to someone else and have their record and their, you know what I mean, all their personal information tied, because that's been someone else's license plate. So if I add one more digit, I've now made this 170, or wait, not there, 175,760,000. Just by adding one more digit to that, I went from 17 million to 175 million different possibilities. Okay? All right, let's move on to factorials. This is something new. Some of you probably have seen it before. If you haven't, the notation is with an exclamation point. Okay? And this is what factorial means. It's dealing with the different combinations and permutations that we're going to look at today. Mathematically, let's look at what this represents. This is 6 times 5 times 4 times 3 times 2 times 1. Not times 0, because the whole thing would be what? 0. This is 6 factorial. So you get 30 times 4, whatever that is, times 3, and so on and so forth. And this is going to give you 720. I'll show you what we do with these numbers here in just a bit, okay? But you need to know how to manipulate these, because on the test, you will have a non-calculator portion, okay? If you didn't do too hot on this last test, you must do well on this one, okay? I mean, as far as depending on where you want your grade to lie, so please make sure that you do not blow this test off. 8 factorial. Look at this. It is 8, 7, 6, 5, 4, 3, 2, 1. The bottom one was 4, 4, 3, 2, 1. And notice the cancellations. The cancellations of forms of 1. The way I would want you to write this out on the test is like this. 8, 7, 6, 5. And then I know the rest is 4 factorial. Over 4 factorial, those cancel. So whatever that is multiplied out to, which in this case is 1680, that's the number of different possibilities, or combinations and permutations that we're going to talk about here in just a bit. Look at this. All I'm doing is algebraic manipulation. 9 factorial, I'd want you to write on your paper like this. And over 6 factorial, 3 factorial. These 6 factorials just canceled. What number did they cancel to? 1. So now I have 9, 8, 7, and then I have 3, 2, 1. I would then, after the cancellation, want you to do something like this, because you're not going to have the calculator. And then you'd identify this will reduce to 3 over 1. This would reduce to 4 over 1. So what you have left is 7, 4, 3, all over 1. So you'd have 12, you see what I'm doing? And 7, so it's just 84 reduced. Questions so far, just mathematically with what's going on with factorials?
So on 976, you kept the exclamation point factorial.
Oh, so that is a question that most people ask. This, don't think of the exclamation point as a number. Think of 6 factorial as 6, 5, 4, 3, 2, 1. And all I did was cancel it with this 6, 5, 4, 3, 2, 1. So the only things left over after this cancellation occurs is that. Okay? And again, this 3 factorial I would rewrite to this. Okay? Don't think this. A factorial by itself is nothing. It's nothing by itself. Like if you had it above itself, this wouldn't cancel to 1 because factorial of nothing is nothing. Okay? Alright, permutations. Permutations, you can put this on your notes. A big thing that permutations and combinations have in common, they both are items that cannot be repeated. Okay? They can't be repeated. But the difference is, permutations, order is important. Okay? And this is where your reading skills come into play. You have to have good reading skills to understand, is this order matters or is this order doesn't matter? So if order matters, it's going to be a permutation. If order doesn't matter, it's going to be a combination. Look at n. N represents the number of elements. This is like if you had a bag of different marbles, the number of marbles that are in this bag is n. R are the specific ones that I want to choose. So if there are 3 red marbles in this bag of 20, R would be 3. If that's what I'm looking for. Okay? And you'll see what I'm talking about here in just a bit. The notation, the way you read this is N, choose R, but it's with a permutation. So you could say permutation N choose R. Permutation N choose R. Okay? And this is how you do it. It'll be N up top, and I didn't have color coordinating when I was in high school seeing this, and it was so weird. But I'm going to highlight that as I go so that you can understand where these numbers come from, okay? Because it does get a little bit crazy, but I'll tell you when that is when we get to it. Number 1. Number 1 says, using the letters of the alphabet, so we know there's 26, you have to create a 3-letter password, but the letters cannot be repeated. How many possibilities are there? So notice the language. how many possibilities, how many ways, and how many different orders. Okay? So if the letters cannot be repeated, first of all, we have 3 letters that we're going to choose from. How many can I choose for the first place? 26. How about the next? 25, right? Because they cannot be repeated. And then 24. So 26 times 25 times 24 would give you 15,600. Now sometimes it's easy to look at it this way, but sometimes you're not going to be asked to solve it out this way. If I asked you to use permutations, okay, the equation, to use with this problem, you would do it like the following. I have 26 permutation of 26, choose 3. This is what you would write on your paper for the test and whatnot without a calculator. Okay, here we go. The equation we will give to you, you will know to put 26 factorial up top. Then you do 26 minus 3 factorial on the bottom. Because the equation showed that n was the total number of things that you had. So you'd have 26 total of these. That goes there and there. And that the other one, which was r, is the ones that we're going to choose. So the only placement on that was there and there. Here we go. We're going to now do this again without a calculator. Guys, please, please, please do not think that this is the same as 26 factorial minus 3 factorial. Those are not the same. They're totally different, okay? Because 26 minus 3 factorial in the denominator, the way it's written, is actually 23 factorial. Because 26 minus 3 is 23. So you would write this as your work, okay? Then you would go on to say, all right, here we go. 26 times 25 times 24 times 23 factorial. Because I don't want to keep going. I'll just group them all together. I have 23 factorial on the bottom, which I know these will cancel to what? 1. And I'm left with 26 times 25 times 24, which is exactly what we did to get 15,600. Make sure you can show this work, though. And you'll understand why here soon when we're at the difficult problems. They don't get all that bad. Okay? Number 2. Yes?
On the non-calculator, how far do we have to solve it? Like just to the 26 and 25?
Oh, so these are a little bit big. They'll be a little bit smaller than this, and you'll just do it by hand. Okay? Let's look at 20. From a class of 20 students, you must elect a president, vice president, and secretary. And how many ways can you do this? So, it's going to be 20, choose how many? 3. Now your question is it going to be a combination, which you'll learn here in just a bit, or is it going to be a permutation? Well, it is a permutation here. And can someone tell me why this is going to be a permutation? Yes, I heard it from all of you guys. For one, you're not selecting the same person more than one position. That's huge. Once that person has been picked for a position, they're done. They cannot be picked for vice president as well. Okay? And then the other thing is order matters. Okay? I'm not picking the secretary and then the vice president and then the president. I'm picking it in a specific order, where order does matter. Okay? So it would be 20, permutation of 20 choose 3. So it's 20 factorial over 20 minus 3 factorial. So it's 20 factorial over 17 factorial. And I would put 20, 19, 18, and then 17. I'm just going to group it all. So therefore I can cancel to a form of 1 right there. And it would be 20 times 19 times 18. Which in this case is 6840. 6,840 different ways. Yeah. Let's look at 3. Again, I want you to be thinking order matters, order matters, order matters. And what are the words that they're saying? Because I won't tell you, hey guys, use permutation to do the following problem. It won't say that. You'll have to decide, okay? So a CD with 11 songs is played with a CD player on non-repeating, there's a key buzzword, shuffle mode. And how many different orders can all the songs be played? So non-repeating you know that it's going to be ordered matters. So it's going to be a permutation. What's the total number of songs? 11. How many are you going to choose? 11. Without doing the work, some of you already kind of think what you think it is because you see an 11 here and 11 here. What do you think it is? To me, if I were sitting where you're at, part of me would go for 1. I think this is 1. But look, this is big. This red 11 right here, the number, the total number, and it'll be total minus the ones we're going to choose. What does the bottom equal? 0. 0 factorial, right? And I'm not going to show you the proof. There's just no time on it, but it's really cool the way the proof works. You can look it up online if you want. 0 factorial is 1. And 11 factorial is 11 times 10 times 9 times 8 times 7, all the way down to times 1. So let's go to the calculator real quick. 11 factorial, your button's right there. It's the second one to the right. And then control enter for the decimal. Whoops. Or you can just press enter and it'll give you the full number, which in this case is 39,916,800 different ways. Okay? Alright. So 30, and that's huge, guys. So there's 11 songs on the CD, and how you could pick them in the order, guys, there's 39,916,800 different ways. Okay? So that's probability, that's permutations. Questions right now. What does this equal? Someone said it. 1. What does this equal? 1. What does this equal? 1. Anything to the power of 0 is 1, except for 0 and infinity. They're not 1. Okay, you'll learn that in calculus. But again, if you have 0 factorial, it is equal to 1. Alright, combinations. Let's look at combinations. Look at this equation and please tell me which one is going to be bigger. Is it going to be a combinations or permutations? Which one of those two would give you a bigger number of different ways? The permutations, yes. The permutations will be bigger of answers because the combinations is going to divide by one more number. So it's going to bring that big number smaller because you're dividing by stuff. For bonus points, can someone tell me what this is representing that distinguishes the fundamental difference between combinations and permutations? Say again? Say again? The removed items, yes, but that's this. You know what I mean? The what? The repeating as far as like what goes?
Like you can use the same object twice.
I'll accept it. Like here's the thing. Let's say that I needed to pick a basketball team of 5 people from this room right now. Okay? And if I picked Jeremy first and then just went down the line, it would be different than if I picked Jeremy second and went down the line. Do you see what I'm saying? If I did permutation, order matters. Okay? But with combination, if I take out, it doesn't matter where Jeremy is, just as long as he's on the team. That's what this is doing here, guys. When I divide by the different ways that I could arrange, the different arrangements is what he was saying, that I can arrange Jeremy in that pool of 5, then I'm only accounting for just Jeremy being on the team. So that's where the combinations come into play. Alright, so this is in choose R. It's a combination in choose R. And the biggest thing is order does not matter. As long as you are on the team, you're on the team. Okay, it doesn't matter if you were picked last or first or in the middle. So it's going to be a smaller number. Here we go. 8 toppings. You can select 3 different toppings for your pizza. How many combinations? Like, it's not always going to say it like that. in your face. How many different combinations are possible? You'd say combination 8, choose 3. Here we go. So 8 is on top. 8 minus 3 factorial. And then we have to divide by r factorial as well. Notice the work. 8 minus 3 is 5 factorial. So you'd say 8, 7, 6, 5 factorial. And the reason why I did that is because I know that these are going to cancel to a form of 1. And then 3 factorial we can write as 3, 2, 1. We still have 8, 7, 6 left to reduce and cancel. And look at this. All that is 6. You with me? So 3 times 2 times 1 is 6. So it'll reduce to, there's 56 different combinations that I can do to get 3 toppings. 3 different toppings. Does that make sense? Okay. Notice that they're different toppings. They're not the same toppings. Alright, 5. From a class of 20 students, you must select a committee of 3. In how many different ways can the committee be formed? So, is it permutation or combination? Say again? It's combination. What's the biggest reason? Guys, this one doesn't tell you what to use. What context clues can you use from this to tell you that this is going to be a combination? That order doesn't matter. It doesn't matter where you're on the committee. It just doesn't matter that you're on the committee. Okay? So it'll be 20, choose R, which is 3. So combination 20 choose R is 20 factorial over 17 factorial, 3 factorial. Okay? You would have 20, 19, 18, 17. And then 3, 2, 1. Those cancel. You can see that this is 6, which would reduce this to 3. So all you really have left to multiply by hand, something like this is what you would see, as far as the level of difficulty that you'd have to do by hand, okay? So 20 times 19 gives you 380 times 3, 0, 4, 2, 9, 1, 1. 1140. 1,140 different ways that you can select or form that committee. From a review with 15 questions, a teacher must pick only 5. How many different combinations of items are possible? This is the same thing, guys. As far as the setup, it's 15 factorial over 15 minus 5, and then times 5. That 5 factorial. And if you do the math and you reduce and you cancel and whatnot, you should get an answer of 3003. Okay. So, how many of you have ever been exposed to this right here? Okay, you should have been exposed to it in Algebra 2. Here we go. Yes. Pascal's triangle is the following. It's dealing with combinations. This is built upon this equation that we started combinations with. Okay? So here we go. 0, choose 0. I'm going to color coordinate this. So it'll be 0 factorial, 0 minus 0 factorial, and then 0 factorial out here. Notice that this 0 is the one right here and here, and that this 0 is the n. It's the total. What does this equal? 1. Nice. Okay. Let's do this one right here. 3, choose 0. That's 3 factorial over 3 minus 0 factorial times on the bottom 0 factorial. This also is 1. Okay, let's do this one way over here. 4 and 4. It's 4 factorial over 4 minus 4 factorial and 4 factorial here. Let me show you where things go. This 4 is this one. It's the total. It's n. This 4 is the r. And it goes right there. Can someone tell me what all that equals? 1. So Pascal's triangle has a cool pattern to it. 1, 1, 1, 1, 1. 1, 1, 1, 1. You can see the triangle already. Okay? Now I'm going to show the math, and then I'll show you the pattern on the next part. Let's look at this one right here. 2 choose 1. It's 2 factorial over 2 minus 1 factorial, and then 1 factorial is right here. Again, this one is R, and this 2 is N. Who can tell me what that equals right there? 2. You want to know the shortcut? The shortcut is this. There is a shortcut, but listen, we're gonna have problems on the test that you're not gonna be able to use this shortcut with it. You're gonna have to learn the last bit that I'm gonna show you here in just a bit. Binomial theorem. It's easier than it sounds, but watch this pattern first. Learn this pattern so that you can understand the binomial theorem better. Okay? So all of these are 1s, the outside. Okay? Then if I add these 2 numbers, I get 2. If I add these 2 numbers, I get 3. If I add these 2 numbers, I get 4, 6, and 4. You with me? So far, the big numbers that are important, that should be screaming at you, are this one, this one, this one, this one, and this one. And I'll show you why here in just a bit. Actually, I'll just show you now. This right here, you've seen this since Algebra 2. Can someone tell me what this is representing right here? What are these numbers representing? 1, 2, and 1. If you can see it, it'll be easier to do the binomial theorem. Okay, so you're there. You're there. It looks like this. So let's say that I had x minus 3. No, let's say x plus 3 squared. Okay, here we go. Can someone tell me what this equals? X squared plus 6x plus 9. Check this out. So how about if I didn't have 3, what if I had 1? What would this equal? X squared plus 2x plus 1. Look at this. 1, 2, 1. 1, 2, 1. You see what I'm saying? You see what's going on here? So this 1, 2, 1 is going to be with these kind. There's a little bit more involved when this is not 1. And I'm going to show you what that looks like here in just a bit. This, in case you don't see it already, is quadratic. You've done it since Algebra 2. It's the x squared family. If you FOIL out. This one is linear because it's x to the 1. And this one's, well, I'll come back to that one. This one's x cubed, this one's x to the 4th. What do you think the top one is? X to the 0, which is what? 1. Okay, so here we go. We have a constant, we have linear, we have quadratic, cubic, quartic, so on and so forth. Now, what if I said down here, what would be these numbers down here? Like for the 5 choose 0, 5 choose 1, so on and so forth. And I'm going to show you some patterns, okay? 5 choose 0, what number goes here? 1. What number goes over here on 5 choose 5? 1. So what would be this one right here? 5, 10, 10, 5, and 1. Now here's the patterns. These are what I want you to identify. This is like saying it's going to be an x to the 5th kind of thing. Just like this was an x to the 4th kind of polynomial. How many terms are in an x to the 4th polynomial? 1, 2, 3, 4, 5. How many terms are there in an x to the 5th polynomial? 6. There's always one more term than the power that you're at. Does that make sense? And here's the pattern that you should see. It's always the second number on the line. Like this is x to the 1, x squared, x cubed, x to the 4th, x to the 5th. It's always the second number that will tell you the power of that thing. Okay? Alright, so now let's do this. So we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Add these two, get 2. Add these, get 3 and 3. Add these, what do I get? 4, 6, 4. And then 5, 10, 10, 5. And then 6, 15, 20, 15, and 6. Guys, these numbers, if I told you to find me the 38th power, and I told you to find me like the 3rd term, who would actually do this all the way to 38 different lines? You don't have time to do that to 38 different lines, just to find the 3rd term. Now when I show you, it does look a little bit crazy. First of all, let's talk about this. Miss Hamilton's funny. Every time you do this, a puppy dies. We were just talking about puppies, so don't kill puppies. X squared plus 3, quantity squared, does it equal x squared plus 9? Or x to the 4th plus 9? No, it does not. That's bad. Don't think that. This, remember, has a multiplicity of 2. And we just did it. That would be first. That would be outside and inside. And then the last. You with me? 3 terms, because the power is 2. And the biggest term is going to be that first term squared. Alright? The last term is going to be the last term squared. Trying to show you patterns here. So, let's move on to the binomial theorem. Here we go. We're going to expand this thing, okay? What's anything to the power of 0? 1. And what's anything to the power of 1? Itself. So now, here we go. This is your pattern, okay? You're going to do Pascal's triangle. So we want to get to the squared piece. Here we go. 1, 1, 1, 1, 2, 1. This is squared, this is linear, and this is a constant of 1. So we want this one right here. Because this is 2, and because this is 2. And remember, the second term in each one of the lines will tell you the power of that polynomial. Here's the pattern. I'm going to start with 1, 2, 1. Then I look at the first term, and I say x to the power of 2. Y to the power of 0. Then I keep going. X to the power of 1, y to the power of 1, and then finally x to the power of 0, and y to the power of what? 2. Because of the fact that this was adding, these will all be positive. So I'm just going to put positive signs there, and there's an understood positive right there for that first piece. And now I just have to simplify this. And I know it looks ugly, but know how to simplify it for your test. So this will be x squared plus what? 2xy plus what? Y squared. Done. They do get more complex. Let me show you the patterns though. This one is going to be x to the power of 3 now. Okay? So we need another line for x to the third. We have 3, 3. So now we have 1, 3, 3, 1. Here we go. 1, 3, 3, 1. The first term is x, so it'll be x cubed, x squared, x to the 1, x to the 0. The last term is y, so it'll be y to the 0, y to the first, y squared, and y to the third. And if you haven't noticed the pattern already, these powers, if you do it right, will add up to 3. Okay? Because of the fact that this is addition, it will be adding in between. If it was subtraction, it would alternate. It would be plus, minus, plus, minus. Okay, but that's not the case here. And now we just have to simplify. Help me out. How do I simplify this? X cubed. Yep, 3x squared y. Good. Plus y cubed. Done. Because x to the 0 and y to the 0 become what, guys? 1. Okay. X to the fourth. One last thing, and then I'll show you the actual equation for the binomial theorem. And that's it. That's a wrap. So we would go one more level. So we'd have 1, 4, 6, 4, 1. So here we go. 1, 4, 6, 4, 1. First term is x. So it'd be x to the fourth, x cubed, x squared, x, and x to the 0. And then y's. Some people like to start from the right. Y to the fourth, y cubed, y squared, y to the 1, and y to the 0. Again, because this is addition, they will all be positive. And this would expand. You will not have the calculator on the test to the following. Plus 6x squared y squared plus 4x y cubed. And guys, you don't have the time to actually do this by hand. You have to use Pascal's triangle because you won't be able to finish it. Because imagine trying to FOIL that out 4 different times. You're doing it. That's what you're doing. You're just saving a lot of time. Alright, the equation is this. Now I know this looks a little bit crazy. And I'm just going to jump to the problem so that you can see what they represent. Okay? This is x to the power of 5. That means if you were to go 5 levels, that's one more after this, I'd have 1, 5, 10, 10, 5, 1. Here we go. That means this is 1 and this is 1. That means this is 5 and this is 5. And that means this is equal to 10 and that is equal to 10. Notice where they're at as far as in the equations that you're seeing. As far as all these coefficients and all these numbers. Because they'll make sense as you piece them all together. Okay? Here we go. I'm going to grab the first term. Let's grab it with blue. This one is going to be x to the 5th. Otherwise, the stuff to the 5th, the stuff to the 4th, the stuff to the 3rd, the stuff to the 2nd, the stuff to the 1st, and the stuff to the 0, which it's not there because it's an understood 1. Okay? And then I'll grab the second term right here. Whoops, maybe not with that color. Let's go red. So, right here, this plus 3, let's go from the right. So it'll be 3 to the 5th, 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1. And again, there's an understood 1 because it's not written there. Okay, but this is where people fall off a little bit. This is where they make mistakes. 2x to the 5th is not 2x to the 5th like this. Because the 5 needs to be applied to both of them. So 2 to the 5th, this piece just right here, becomes the 32 that you see right there. Okay? And then 16x to the 4th times 5. This 16 times 5. Then times 3. There's a lot going on right here. This times this will get you that. And it's x to the 4th. 8, 9, and 10 give you 720. But again, the biggest thing is whenever you're going to do this without a calculator, you got to make sure that you know 2x cubed, like this, will become 8x cubed, which is what they wrote here. And then you just simplify everything and then piece it all together without a calculator. Questions on this? Okay, let me ask you this. Because this is a 5, how many terms will your answer have? 6. 1, 2, 3, 4, 5, 6. You with me? And because this is a 5, that means the first 5 will appear here. Not on the first term, because the first term is always what? 1. And the last term is always 1. Because you see, it's like this evenness to it. All those are 1s, and then they have an evenness flow to it as far as the way they go out. Oh, she's I foiled your plan. Anyway, okay. So this is the last one. I'll do this as an example. I'll let you look at 2 and 3 from your notes, but this is the last one, and we are done. All right. Let's expand this one together. There's 4. So how many terms? 5. And the first one is going to be 5, choose 0. True or false? False. It's going to be what instead of 5, choose 0, guys? 4, choose 0. And then 4, choose 1. 4, choose 2. 4, choose what? 3. And then 4, choose 5. This is the equation of how it just goes. Basically, 0, 1, 2, 3, 4, all the way to 5, choose 5. Oh, my bad. This needs to be what? 4. So, 0, 1, 2, and then 3, 4. Okay? We know that 4, choose 0 is what? 1. And we know that 4, choose 4 is what? 1. But if you don't know what 4, choose 1 is, like this one right here, let's do it real quick without a calculator. 4, choose 1, remember these are combinations, are going to be 4 factorial over 4 minus 1 factorial, and then that 1 factorial here. And I keep doing this because it's R, and I keep doing this because it's N. 4 factorial over 3 factorial. What does this equal? Someone said it. 4. So that means this one is also going to be what? 4. So now let's find out what this coefficient is. I'm doing this without the triangle, okay? So 4, choose 2 is the same as 4, 4 minus 2, and then 2. So this is simplifying to 4 and 2 and 2. So 2 factorial and 2 factorial, and then 4 up top. What does this equal? 6. Nice. So it'll be 1, 4, 6, 4, 1. Okay? Here we go. The first term is x, so we'll say x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. Or you can just put 1 there. You don't have to write x to the 0. Here we go. 5 would be 5 to the 4th, 5 to the 3rd, 5 squared, 5, notice my parentheses use, and then 5 to the 0. Because this is subtraction, it will start with positive, then negative, then positive, then negative, then positive. Remember, you always start positive and then alternate if this is subtraction. And here we go. 1 and 5 to the 0. What does that equal? 1. So it's x to the 4th. 4 and 5 to the 1. What does that equal? Negative 20. Okay. Then you have 6 and what is that? 25. So So it's going to be 150x squared, right? And then you have 4, and what's that? What's 125 times 4? 500. So 500x, and then 5 to the 4th. What's 5 to the 4th? Well, 5 squared is 25. 25 times 25 is 625. This is the level that you'd have to do without a calculator. Okay? Questions? Alright, that's all we got.